Hi everybody, it's Professor LaShanna. I'm going to do some video going over the examples from section 5.2 in the textbook. So I'm starting on page 246, example 1 from the textbook. So it says, a national study found that college students with jobs worked an average of 22 hours per week. So that is our population mean mu, 22 hours per week, with a standard deviation of sigma, 9 hours per week. A college student with a job is selected at random. Find the probability the student works for less than 4 hours per week. So our x value is 4, and less than tells us where to shade. Assume the lengths of the time college students work are normally distributed and are represented by the variable x. So we can apply all of our normal distribution charts and tables and graphs and all of that. So the first thing we're going to do is we're going to draw the picture. So we draw a normal distribution, a normal curve with a mean of the population in the middle of 22. Our data value x is much less than 22, so it's to the left of the mean, and less than tells us to shade to the left. So once we have that picture, and this is our answer, but we'll come back to that, we're going to calculate our z-score. And we're going to use this z-score formula, which you got from the formulas page that I scanned in and sent out, for what I call the shorter z formula when you convert a data value x to a z-score. X minus mu over sigma, using population values for population mean and standard deviation. So we're going to take x4 minus the population mean 22 mu over sigma 9 standard deviation, which gives me negative 18 over 9, which is negative 2. So then taking that value of negative 2 for our z-score, we need to have 2 decimal places on a z-score. So we're going to make that negative 2.00. And then we're going to go to our z-table at negative 2, and it might be hard for you to see here a little bit because my lighting's not the greatest. But I'm going to go to negative 2.0, and you all should have the table either in the back of your book or print it out. And so I'm going to go to negative 2.0 and then down till I'm under 0 hundredths. And what I get in that table, if you can see it above my pen, is 0.0228. And that is always the area to the left of whatever you're looking up, as the picture shows. So if I go back to my picture, I wanted the area to the left. And so the area to the left that I've shaded, we looked up, was 0.0228, and that's my answer. That's the probability that a randomly selected college student would be working less than 4 hours per week. 0.0228, a little more than 2%, which is unusual. Anything less than 5% is considered unlikely or unusual. So now if I go to example 2 on page 247, this is a 4-part example, so it's kind of a long example. So example 2 says, a survey indicates that for each trip to a supermarket, a shopper spends an average of 43 minutes. So that's our mean, mu, 43 minutes, with a standard deviation of 12 minutes. That's sigma, our population standard deviation. The lengths of time spent in the store are normally distributed, so we can apply our normal distribution formula for z. We can apply our charts and tables and graphs and all of that for the normal distribution. They're represented by the variable x, the time spent in the store. A shopper enters the store. A, find the probability the shopper will be in the store for each interval of time listed below, and they give us 2 intervals of time there. And then B, when 200 shoppers enter the store, how many shoppers would you expect to be in the store for each interval of time? Okay, so the first question is between 22 and 52 minutes. Between is the key word here. So when I draw that picture, I'm going to put the mean mu in the middle of 43 here, and 22 minutes is less than 43, so that's to the left of the mean. 52 minutes is more than 43, so that's to the right of the mean, and I'm shading between, as it says in blue. So I'm going to go over here, and I'm going to calculate z-scores for 22 and 52 minutes. So first, starting with x is 22, it should be a negative z-score because we're to the left of the mean. So here, x22 minus our mean of 43 over the standard deviation of 12. That's going to give me negative 21 over 12. Subtract first, then divide. You get negative 1.75. For x is 52, which is to the right of the mean, that should have a positive z-score. We take x52 minus the population mean 43 mu over the standard deviation sigma of 12. Subtract first, you get 9 over 12, 0.75. So that's our z-score for 52. So now I go and I look both of those up in the z-table. So starting with the negative 1.75, and again, you all should have the z-table. You should print out a copy, or you have a copy in the appendices. You should have a copy in the back of the book if you have a physical book. So if I go to row negative 1.7 and then 500, here's my value, 0.0401. That is the area to the left of 22, where the z-score is negative 1.75. So I'm putting it over here in the left tail, right here in purple, 0.0401, because that's how our table works. It gives us area to the left. Then when I look up the z-score of positive 0.75, on the positive z side of the table, I go to row 0.7, and then 500ths, I go down to 500ths, I get this number, 0.7734. So again, I go back to my drawing. Here, x is 52, the z-score was 0.75. The area to the left, all of the area to the left, all the way to the left tail is 0.7734. So of that 0.7734, we want to take away the unshaded part in the left tail of 0.0401. So that's how we're going to get our answer here. Let me move my camera down. So that's how we're going to get our answer. We're going to take the 0.7734, all of this, and subtract off the unshaded 0.0401, which gives us our answer of 0.7333. That's the probability that a shopper will enter the store and spend between 22 and 52 minutes. A little more than 73%. Not unlikely, not unusual. So now we're going to go down to question 1b. What if there are 200 shoppers entering the store? What is the probability that 200 shoppers will enter the store? What's the probability that they will spend between 22 and 52 minutes? How many of them, I should say. So we're going to take, this is the probability for one shopper, 0.7333. We now have 200 shoppers in our sample size, so we're going to take 0.7333, that proportion of or times 200 shoppers, which gives me 146.66 shoppers. You can't have 0.66 shoppers, so you look in the tens places of 6. You round up, you can only have whole shoppers. So the answer to 1b would be about 147 of every 200 shoppers we could expect to enter that store and spend between 22 and 52 minutes in normal shopping days, right? Not like today. So now we're going to go to question, example 2, question 2a and b, because there are 2 more parts to that. So example 2 on page 247, now we've got 2a. What's the probability that a random shopper will enter the store and spend more than 37 minutes in the store? So we've got x is 37 and more than tells us where to shade. So we go over here to the picture. Again, our mean of the population was 43. That goes in the middle of the drawing. 37 is less than the mean, so that goes to the left, because fewer minutes than 43. But it says more than 37 minutes, so we're going to shade to the right in blue here. That's the people who spend up to 43 and then longer than 43 minutes. So again, we're going to use our z formula. We're going to calculate a z-score for x is 37, which we expect to be negative because we're to the left of the mean. So we take x 37 minus the mean 43 over the standard deviation 12, subtract first, negative 6 over 12 is going to give me negative 0.5, but we need to add a 0 because z-scores need 2 decimal places to look them up in our table. So if I go to my table and I'm looking up this z-score of negative 0.50, I'm in row negative 0.5 towards the bottom here, and I go all the way down until I'm under 0 hundredths, which gives me an area of 0.3085. So that's my area to the left, because that's how our table works. When we look up area, we get the area to the left. So here's the area in the left tail, 0.3085. That's not what I want. I want the area to the right. So we have to use the idea that the total area under the curve is always 1 or 100%, and subtract 1 or 100% minus the unshaded part in the left tail, 0.3085. That's going to give me the area to the right. That's basically what you always do if you want area to the right. 1 minus that area to the left that's unshaded. That gives me an area of 0.6915. So that's probably that one shopper will enter the store and spend more than 37 minutes, about a little more than 69%. So not unlikely, not unusual. So now we go to question 2B. What if there are 200 shoppers that enter the store? How many of them would you expect to spend more than 37 minutes? So the proportion or the probability that one shopper would spend more than 37 minutes, 0.6915, or that's the proportion of shoppers. So we're going to take that area or probability, 0.6915, of or times our 200 shoppers in the sample, which is going to give me 138.3 shoppers. But you can't have 0.3 shoppers, so the closest whole number, if you look in the tens place, is the 3, so you keep it the same. It's about 138 shoppers you could expect out of every 200. That squiggly thing means approximately equal to. About 138 shoppers you would expect to spend more than 37 minutes in the store if you had 200 shoppers entering the store, which hopefully we won't know now in our time of social distancing, right? So we're going to finish up one last example. Let's go to example 3 from section 5.2, which is on page 248. So this one says, and by the way, these were all real data, which is cool, so it's not just made up information. It says triglycerides are a type of fat in the bloodstream. The mean triglyceride levels for adults, U.S. adults age 20 and older, is 97 milligrams per deciliter. So that's our population mean, with a standard deviation of 25 milligrams per deciliter. So that's sigma, our population standard deviation. Assume that triglyceride levels are, for adults at least 20, are normally distributed. So we can apply all of our normal distribution formulas and charts and all of that, drawings. You randomly select a U.S. adult who is at least 20. What is the probability that this person's triglyceride level is less than 100? Less than 100. So our X value is 100, and less than tells us to shade to the left. So if I go over and make the drawing here, in the middle goes our population mean of 97, here in the black. Our X value of 100 is more than 97, so it's a person who's a little bit unhealthy when it comes to triglycerides. And less than means we shade to the left, all the way to the left tail. So we're going to convert that 100 X value into a Z-score, again, using the shorter Z formula. So we're going to take X100 minus the mean of the population, 97, divided by the standard deviation, 25. Subtract first. You have 3 over 25, which gives you 0.12 exactly. So no rounding necessary. If they hadn't come out exactly, you would need to round to 2 decimal places. So that, because that's how our table works, it has exactly 2 decimal places. So we're going to go to the positive Z side of the table. We're going to look up 0.12 in our positive Z side of the table. Oops, let me move this down so you can see it in the right spot here. So row 0.1, and then under 200ths, which gives you an area of 0.5478 above my pen here. That is the area where? To the left. So all of this blue shaded area to the left is 0.5478, because that's how our table works. It gives you the area to the left, all of this. So that's what we want, the area to the left. So our answer is that the probability that a randomly selected adult will have a triglyceride level of less than 100 is this area that we've shaded, 0.5478, that we got when we looked up 0.12 and got the area to the left. And that's our answer. So not unlikely, not unusual, almost 55% probability. So there's section 5.2. Hope you enjoyed it.